I kind of have this weird way of dealing with people that are trying to start their own company. I've sat down and talked to Tim Medine, and I've talked with Chris and Matt Toussaint and a bunch of people. And the conversation always starts out the same. Anytime somebody's like, yeah, I'd like to start a company, and can I pretty please like sit down and have some of your time to learn how to do that? And almost universally, I say, yeah, okay, so to start, don't. Trying to start a business looks like it's absolutely fantastic. And the reality of this situation is a lot of late nights and a tremendous lack of sleep, white knuckle fear when you wake up in the morning, almost every single morning for the first 6 years of running your company. Whenever you hire people, you're constantly worried about hiring the right people. Hiring friends can be great. It can be a pitfall. But I go through all of the different trials and tribulations that Eric and I went through when we started BHIS, as in, starting a company in the economic collapse of 2008, basically had something like $30,000 in credit card debt. We were down to one vehicle that was a mouse-infested van that, seriously, we put down mouse sticky traps so we catch like 12 or 13 mice a night. It was insane. And everything was just absolutely falling apart, and really starting to think that it was an incredibly bad idea to start this company and to try to kick it off. But slowly things started happening. We started getting more SANS conferences and started getting contract gigs. And over time, it got better. But I think it's always important whenever you talk to somebody that's trying to start a business to let them know that they should not start their own business. It is absolutely terrifying, and it's horrible, and it's evil. And then I kind of sit and I wait and get a feel for what that person's thinking. And I've actually talked to some people that were talking about starting their own business, and they had no idea on how to get work. They had no idea for templates. They had no idea about insurance. And the correct answer whenever you're talking with me about starting your own business is to go away and just don't do that. Chris is one of those people that after I gave him the whole long spiel about how hard it is to start a company, he was still there, and he was excited, and he was willing to do the things that absolutely needed to be done and face the peril, I suppose, and do it without loss of enthusiasm. And never once have I seen him lose the smile on his face for all the things that he's done. We are very proud of the fact that we get to work with Chris and his team. I am very proud of the fact that I can say that Chris is somebody that we absolutely work with, and our people go and do his training. It is without question one of the better relationships for BHIS on a professional level, but also on a personal level. You couldn't find a better person to be partnered up with. And I know that he's had white knuckle feared nights. I know that he's been afraid, and we've been trying our best to kind of help each other through being small businesses and trying to navigate the waters of information security pen testing. So with that, I'm very happy to announce Chris and Matt, and they're going to be talking about building a fully functional command and control with Azure. So Chris, is your mic fired up and ready to go, sir?
Yes, sir. I am ready.
All right, well, take it away. Thank you so much.
Thank you so much, John. Thank you for those kind words. And I think the biggest thing I took away at that is at least finally after 6 years, I can stop having as much fear, at least every day when I wake up. Thank you again for the introduction. Myself and Matt Grandy are here, and we are here to talk about Azure Functions. These are what I would say are probably the two least important slides you're about to see, because we're going to get into the content shortly. But just to give some background why we feel like we can talk about this is my name is Chris Truncer. I'm one of the co-founders of a security company called 40 North Security. I am our offensive security lead. I started as a sysadmin, played with servers for quite some time, and I've slowly learned over my career to try to write some code and hopefully make sure that it works. I like to contribute a lot of code back to open source community, so I've worked on projects like Veil, Eyewitness, Women Implant, and a couple other ones. It's what I like to do, and I enjoy coding. Matt, I'll turn it over to you real quick.
My name is Matt Grandy. I'm a senior offensive security engineer at 40 North. I came on to 40 North probably half a year ago now, something like that. I've loved it here ever since. I say I'm a Python C# developer with quotes because I'm not good at all. I think Google and Stack Overflow save my life every day, but I'm working on it and getting better every day with that, and love doing that developer work as well. And living in Colorado, I have to say that I love the outdoors and I love backpacking and all that stuff as well.
Yeah, that's fair. I think all of us are pretty much, or at least myself included, Google, Stack Overflow, and GitHub, just praying someone else has some code that I can use. So I feel you there. All right, so let's talk. What does this talk about? Well, we're going to dive in, not really dive in, but talk at a high level about what Azure is. We're going to talk or discuss red team infrastructure, how it works, and how you can use it within Azure. And finally, we're going to discuss at a high level, what does C2 infrastructure look like? What does the traffic flow from a victim system to all the way back to our command and control server? And can we replace redirectors or can we replace them with something else? So that's what we're going to discuss today, amongst an extra section that Matt is going to add in at the end. That's a cool little trick. So let's talk Azure. So Azure is Microsoft's cloud service offering. This is obviously a competitor to Amazon's AWS cloud services. Most people think about AWS or Azure. What sort of functionality do people usually think about, or really any cloud provider? Well, it's usually always on capability if we need it, right? High availability. I hope that my code that I have running somewhere or a server is never going to go down. That's not something that I should really have to worry about. Now, obviously, that's not always the case. But also along with that, we are talking a lot about computing resources, right? Like that's probably the first thing that I think of with really any sort of quote cloud provider out there is just the ability to offload servers or computers or virtual machines. So people probably are used to seeing something like this if you've ever used Azure. Long story short, this is just basically what you're going to see when looking at the status of a specific virtual machine that you have running within Azure. Obviously, EC2 and Amazon has their own portal page that you would use as well, but that's not the focus of what we're talking about today. So computing is really the first capability that most people associate with cloud service. If that's not true, then that's at least for everyone, that's at least true for me. That's what I usually look to. It's typically going to be a core offering of every cloud provider as well. So the good thing to note is that there's a lot more out there than that Azure and other providers can offer. Obviously, storage is one. Storage is also something that people can misconfigure. As everyone is aware, you can always encounter companies or always see in the news, it seems like some company has left their S3 bucket insecure and accessible by everyone. However, when done properly, you can legitimately store data in the cloud and have it fairly locked down. There's also database services that you can use. Well, another one that attackers and offensive security professionals have started to really dive into recently are CDNs, or content delivery networks. Azure is super useful because it can provide you access to multiple CDNs. So Microsoft has their own content delivery network. You can also use Verizon's content delivery network straight through Azure. The other interesting one is Akamai. When I was looking a while ago to try to figure out how can I leverage Akamai for domain fronting or to just legitimately use the CDN, I was trying to find online like places that I can register for it, Akamai's own site or other resellers have access to the CDN. And it seemed either incredibly hard to become a part of, like you had to basically upfront pay a lot of money to have these services on a retainer, or it wasn't easy to figure out like how to just gain access to the service. And I just happened to look on Microsoft's on Azure to check out the different CDN providers that you can select from. And lo and behold, Akamai is actually one of them. If you're ever looking to use a CDN, especially from an offensive security perspective, my other concern was, what's the cost of this going to be? If I'm sending traffic back and forth when I'm performing my assessments, what am I looking at price range wise? And remember the first time I had used Akamai, I was a little worried because I had no idea what it was, but I was going to eat the cost, whatever it was, because I needed to know what sort of price range are we going to look at when using these. And after about a month test and a successful test where we were sending a lot of data back and forth, finally got the bill, and I think it was like 73 cents. So it's incredibly cheap to use, and Azure makes it very accessible. So I would highly recommend checking that out if you're looking to gain access to that CDN. So why do we care about CDNs though? Well, let's talk high-level C2 Attacker Tradecraft. So here's my personal example of a person that doesn't know how to use Visio trying to make a document, a graphic through it. But typically the way C2 traffic is usually done, and most people may already know this, is when a system is compromised, it obviously works its way first through the firewall. And the goal is obviously to get back to the C2 server that the attacker controls. Well, if we're doing this properly, the last thing that we ever want to do is have a direct connection straight from the system that's compromised directly to the team server. You generally want to hide your team server, whatever your end C2 server is that you're using from the victim system, because there's a lot of ramifications that can come from it. We're talking either investigations into it, we're talking about straight up blocking that traffic. There's a bunch of things you'd have to account for. So the normal way that most people typically establish command and control is they will have the victim system go, once it goes through the firewall, through something called like a redirector. And this can be a dumb redirector, such as like IP tables, where any traffic that comes in on, let's say, port 443 for HTTPS is going to be immediately redirected to the team server. And then whenever the team server responds, it goes back through that redirector back to that victim PC. You can have something such as a smart redirector, where maybe you are using Apache rewrite rules. Maybe you have Nginx configured to look for incoming web requests and then route them appropriately to the team server, only if it is a legitimate request from a system that you have compromised. If there's anything that's off about that request, send it to some other third-party site. So that's obviously, we're applying some logic to the rules and the way that traffic is sent. Well, a couple of years ago, this concept of domain fronting came out, and it's pretty awesome. I think most assessments that we do today, we are using domain fronting. I think most people that I've worked with also like to use domain fronting. And the nice thing about that is we can use highly reputable domains to basically send our command and control traffic to our team server. And the way that we're able to do that is by taking advantage of how CDN works. And we're going to get into a slide discussing that at a high level real quickly. But the big takeaway from this is domain fronting can act as our own redirector in that case as well. We don't actually need a physical server or a virtual server to forward our traffic. The cloud, the content delivery network can do that for us. So domain fronting lets us use highly reputable domains to hide our C2 traffic. So it's great because we can have our victim system look like it's making a web request to a subdomain of CNN.com, Microsoft.com, any basically highly reputable domain that you can think of. However, because of the way that the host header works in the web request, when that request gets to the content delivery network, rather than going to the legitimate location that it's supposed to go to, we can basically hijack that request and have it sent to our malicious server. That way, the cloud, or the CDN, is basically acting as our own redirector. This is nice because it eliminates the need for a virtual system, and the reputable domain and the CDN itself really is our own redirector in this case. So if we're going to look at how this works, again, relatively high level. In this case, we have our victim system that is making a web request to cnntechlive.cloudfront.com or cnn.com. When this hits the CDN, if we have not modified the host header in any way and it's a legitimate request, it would go, the CDN would just forward it on to the actual server owned by CNN or the endpoint owned by CNN, and the content will come back like normal. However, if we modify our request and actually change it to point to our malicious server, it'll still look like, from a web request perspective, that this victim system made a request to cnntechlive.cloudfront.com, but with the host header sending it to a different C2 server, specifically in this case, attacker endpoint.cloudfront.net, the CDN is going to send it over to our server where we can stage commands. So we can tell the victim system to return us a process listing, take a screenshot, let's download a file. The big thing is we are just leveraging legitimate functionality in how a CDN works to make sure that the web traffic goes to us instead of the real location, all while using the highly reputable domain as our C2 domain. So domain fronting gives us the ability to use, again, highly reputable domains for C2. Another takeaway is that it eliminates the need for an actual redirector system. We can build in special rules to help filter incoming requests. Steve Bohr has actually written a bunch of great blog posts on using Azure and the premium functionality of Azure CDNs to write rules. So you can almost make a smart redirector similar to Apache rewrite rules or different Nginx configurations, all within the CDN to filter traffic based upon the incoming requests. The nice thing is it's not a single server or system that can go down and break all of your comms between you and the systems that you've compromised. You have a single system hosted somewhere that's handling all your traffic, and for whatever reason it gets corrupt. Until you change either DNS records and stand up another server, all comms are down. That's really not the case with the CDN because there's not a single system that the CDN resides on. It's in the quote cloud. Well, so speaking of this, is there any really other cloud functionality that can give similar capabilities, not necessarily maybe the same or maybe more or just something close to it. Azure Functions can present another option for people out here. So let's talk about Azure Functions. So what are they? Azure Functions you can think of are as serverless code, right? So this is Microsoft's Azure version of AWS Lambda. They are event-driven functions which do something. So you provide code and it will run your code. It will run whatever function that you provide. The nice thing about using Azure Functions is that they support a wide range of languages for you to develop something in. So we're talking C#, Python, PowerShell, Node, JavaScript, PHP. I think there are a couple other options as well. So if we're talking about trying to replace a redirector or how redirectors work right now, why should we have to deploy an entire virtual machine, so stand up our own virtual server, that just does Apache smart rewrite rules or is a dumb redirector with IP tables? Why stand up an entire virtual machine, a virtual server somewhere to perform that role when all we need is really 25 lines of Python code that can perform the same exact functionality? Well, the nice thing is all we need to do is write that code, which conducts any action that we need it to perform, and then have a trigger which invokes our function or code to run. We can do that with Azure Functions. We think of what a redirector needs to do, right? What does it need to do? So as a request comes in, it just forwards that request onto the team server, and then it receives the response and sends it back to the victim system. So it's pretty easy from a Python coding or really any language perspective to write code that receives an incoming web request, makes another web request, and then once it receives that response, it returns that response to the original request. We're kind of almost man-in-the-middling our own request, but not really. Well, if we have code that can accomplish that, the next question would be, well, how can we trigger it? Well, thankfully, Azure Functions have a lot of different options for you to trigger your code. One of the hard things with functions, when it comes to trying to deploy them, is to packaging it up in a way that's digestible by Azure and making it easy to just like throw it all in a zip and upload it to Azure. Well, thankfully, Microsoft writes software, obviously, that most people probably know, called VS Code. Visual Studio Code makes it incredibly easy to package your Azure function code in a format that works for Azure and uploads it to Azure itself. Like all you basically need to do is click a single button, tell it to deploy, and then VS Code will handle everything else and get it uploaded into Azure and get your code running. There are multiple triggers that you can use, like I mentioned. Anytime a trigger hits and is basically run or invoked, that trigger will then target your function and tell it to run. So here's just a quick example, or just to show. Visual Studio Code, as everyone knows, probably has a large number of different functionality or plugins that you can add to it, one of them being an official plugin from Microsoft Azure. They have one specifically for functions. If you ever want to play with Azure Functions and test out deploying function code into Azure, this would be what you want to use, because all you need to do is just install it. It can ask you to log into your Azure account, and then you'll be provided with options with just a single button up here that all you need to do is click it, and it will push your code into Azure. So I kept talking about different triggers that are available. Let's discuss some of these, like how these work. There are multiple triggers that you can choose from when building your Azure function. It's a required piece of your function. You can't just write function code that is never triggered. It's basically like a piece that has to go along with it. You have to provide some sort of a trigger that exists that will cause it to be invoked. Timers are an option. You can kind of think of this as a scheduled task that is scheduled to run your function at a specific time or day or something like that. You have blob storage as an Azure function, where you can have your Azure functional code run anytime Azure blob files are written or modified, or somehow storage data is modified. The one that we're going to use in this case is an HTTP trigger. This is probably, at least in my opinion, one of the easiest triggers that you can work with, right? Whenever a web request comes into a specific URL, that can invoke your code. So I think you can probably see where we're going with this in relation to redirectors. Here's an example. When you are creating an Azure function, it'll ask you what type of trigger do you want to use. So you can pick between all of these different triggers here. The one that we are using, and probably what most people would use for a C2 platform, if you will, is going to be an HTTP trigger. Right over here is actually that button. You can see this nice up arrow. whenever your code is done and saved and you want to deploy it, all you need to do is click that, and VS Code is incredibly kind and easy and will upload it to Azure. So if you want to do it the slightly harder way and create a function right through the portal within Azure, it's pretty easy to do. It's just all within all services, the compute section of Azure, and then you can see there's this option for creating a function app. All you do is once you create a function app and get into that area is just click the big old plus button, this add option here on the side, and then it's going to start walking you through, okay, what do you want to do? Like, what should your function build? Keep in mind, we're going to show the GUI portal way. If you use Visual Studio Code, it's going to walk you through most of these exact same steps. So once you get here, this is going to be, once you hit this plus button, to add a function, you're going to be presented with this screen. It's going to ask you some of the basics that, just like any Azure resource that you want to build, like what's your subscription, what resource group do you want it to go under, or you can create a new one. The big one here is where you're going to provide a function name. In this case, we just have 40 North Security. And what we're going to talk about is, what are you going to publish? Like, what is your Azure function going to do? Is it code, or is it a Docker container that's running? For this example and our proof of concept code that we've published, we're going to just use code. Pretty easy enough where once we select code, you can drop down and see what languages are available to you. So in this case, we have .NET Core, Node, Python, Java, PowerShell Core, but there are other languages supported such as C#. In this case, we can actually even select the version of Python that we want to use, and we can specify the region that it's going to be deployed in. The really nice thing about this, and what makes Azure Functions pretty nice from an attacker's perspective, is you get to use the Azure Websites.net domain for C2. You can establish your own subdomain that gets published within that Azure Websites.net domain. This is pretty awesome from an attacker's perspective, because we are still going to be writing upon a pretty reputable website, or a pretty reputable domain. So you might want to pick something related to your client, right? Like if I'm testing BHIS, maybe I want to have like BHIS code repo, and then it would be my function name, and the URL would be BHIS code repo, Azure Websites.net. Or maybe you want to have a standard service like Microsoft Update, or just something that does not stand out at all, like web delivery, CDN delivery, anything like that that just looks like very standard, boring web traffic. Once you hit create, that's all you really need to do. And now you can start working on building out your Azure function code. For this presentation, for the code that we published online, which we'll link to at the end of this presentation, we wrote ours in Python because most people seem to usually have some understanding of Python. Quite obviously, you could translate this into any other language supported by Azure Functions. So in this case, as you can see, when you create your function app name, though, this is where you get to pick the subdomain of Azure Websites.net. It's really nice because as you change this, it will tell you if it's taken or not. And so you can really just test out pretty easily what's a really good subdomain that you might want to use that you think is not going to stand out as if anyone inspects these web requests. So one thing to note is you are going to have the ability to set the subdomain for your Azure function. But Azure is going to give you a URI based off of your function name. So you can think of this as like the overall function container. And this is obviously the subdomain that's going to be used. Within this overall container, you may have multiple functions. So like one function may be for GET requests, one function may be for POST requests. So those sub-functions, for lack of a better term, are going to be included in the URI of your web trigger that invokes your code. So if you are using Cobalt Strike, when you work on developing your malleable profile, if you want to use this for command and control, you're probably going to have to write your function code first and then build out your malleable profile for C2. And that is because it's just to make sure that the URIs match up for your GET requests or your POST requests with the web triggers of your Azure functions as you continue. You're probably going to need 3 separate sub-functions that you're going to use in your overall function when you use Cobalt Strike. So what might those be? Well, one is probably going to be for posting data, like as your C2 receives data, like maybe you took a screenshot, maybe you have different process listings that you want to, or maybe you ask it to give me a process listing and you're going to receive all that data back. Well, you need to have a post request, right? Because that data is sent back to you in a post request. You're probably going to want a GET request because that is how Beacon looks for tasking. You may also want different stagers, like a request for each stager, depending upon how you plan on dressing up your malleable C2. Really, the limit here is just up to your imagination. You can do as many or as few as you want to. One thing to also note, especially if you're using Cobalt Strike, is you are probably going to want to pass your Beacon ID or metadata as cookies or just as a header sent in the web request, because it's going to be pretty easy to go ahead and parse those with your function code. It's not going to be easy if you're using URI append. Now, obviously, you can add some logic to your function, but at this point, you're starting to complicate things. I like stuff that's fairly simple. So I know we talked a lot about this from an abstract perspective. Let's start looking at some code. This is going to be what you're seeing when you first build out, not this code, but you're going to have just a couple basic imports listed here for your base template for your Azure function. What I wanted to do is make basically a function that just forwards on my web request. And so that's exactly what I'm doing here. In this case, I'm basically monkey patching SSL to tell it to ignore unsigned certs just for the sake of this demo. And what you can see is I'm setting this IP address and this URL for where my GET request is going to go to. What's happening then, the next step is as this web request comes in, so I'm going to parse all of the headers that are sent to me in the web request sent to my Azure function so that I can contain that data. Why do I need to have those headers again? Well, that's how Cobalt Strike and possibly other C2 frameworks uniquely identify each incoming beacon. They need to have that data stored somewhere, right? So one of the easiest places can be in the header of a request. After I've gotten all of this data from the incoming request that comes into my function, well, I'm going to go ahead and basically recreate that request to my team server. So all I'm doing is making a GET request to the team server, passing along all the headers that came in, and then once I receive the response back, send that back to the original requesting system. Same concept with post request. The only difference here is that we're going to be making a post. We are getting the body of the post request sent into this function, and then we are making that same post request to our team server at this location right here. You'll notice the URIs are obviously slightly different. We're going to dive into this a little bit more, and we're going to have a video demo that will show how this works. This is the same concept again for if I'm staging. If I want to have Azure Functions act as my redirector for any staging requests, you can do that exact same thing. And in this case, we don't have to worry about necessarily the headers. We can just forward on the request, receive the response, and return it back to the requesting system. One thing to note is when you write your functions, they're going to have a function.json file that is included with your base template. To make life really easy on you guys, if you do start deciding to play with Azure Functions, just use the base template and use Visual Studio Code, and it will build out all of these base files that you need. And so you have a template that you can start with, and it makes life so much easier because it has everything that you need to work up and going from the beginning that you created. One of those files, again, is going to be this function.json file. One of the attributes of this file is how is your function allowed to be accessed? What is allowed to trigger it? Do you want anyone to be able to trigger it, or do you have to provide a password, if you will? Probably the top 3 ways, at least when it comes to a web request, to set up what access is allowed, is going to be through either a functional key, a master key, or anonymous. The functional key, the way that this works is you can think of it as, remember, for each sub function, so not the overall function, but each sub function that's contained within your function container, you can generate what is similar to an API key. It's not an API key, but it's similar to that. And anything that makes a request to that function has to pass that API key along with it. If it's not included, then it will not run your code. It will not trigger it. It will basically just ignore it. There is a master key. So a master key, you can think of it as an API key at the overall function container level. You must have an API key that can trigger any Azure function app. And in order to use that, you would just generate one within Azure and then pass that along with your web request. If you do not pass that along, then function will never be triggered. What we likely want is this last option, anonymous request. Just like it sounds, it does not require a key at all. It is just something that anytime anyone hits it, then it will just trigger your code and you're good to go. So that's probably what's going to work best for us, at least in this initial POC that we published for everyone when trying to use Azure Functions. Here's an example. Within the function.json file is where you would provide the authentication level required. You would either provide functional, master key, or you can specify you want it to be anonymous. And once you push this code to Azure, anyone that has the URL to trigger your code will be able to trigger it. Here is where, in the event that you wanted to actually build out, let's say, a functional key, this is within Azure's portal. This would be the overall high-level project. Git is one of the sub-functions within this overall function. And then within the manage section of your sub-function, you can click to add and build a functional key, which would be passing your request. Now, this is only if you want to have that requirement, that quote API key, for lack of a better term, in order to trigger your code. You don't need to do this if you are using anonymous access. So again, like I mentioned, if you're coding your function in Visual Studio Code, it just makes life so easy for pushing it. You don't have to worry about packaging anything up. Just use the built-in Azure function, authenticate to Azure through Visual Studio Code. And once you're happy with it, code will automate pushing and deploying it to Azure, and it will make life super easy for you. You can see at the bottom, in this case, we were playing with the function name, the overall one called Web Delivery Online. And this is after I pushed it. At the very end of deploying everything, it says these are your trigger URLs. If you make a GET request to any of these, it will trigger the function code behind that. And here's just another example where we can find like what is the base high-level URL that we would use. In this case, it is Web Delivery Online, but to actually trigger it, we would include the rest of these URLs within our request. So the big thing is now, let's say you do have your Azure function code published, everything's looking good. We now have, these are the trigger URLs, which will basically forward on a request, whether it's a GET request, post request, or staging request. Well, now you're gonna have to modify your malleable profile. You need to make sure that the URIs used by your HTTP GET sections, your HTTP post sections work and are functional and compatible with the code that you have set up based off of your Azure functions. And the big thing is make sure your metadata, which uniquely identifies each beacon, is stored, in this case for our proof of concept, within the header, because you're already passing all headers along with your web request, and then Cobalt Strike has everything that it needs in order to. So like here's an example, we have our HTTP GET, the URI, in this case we were setting API/GET, and you're including our metadata within a header. In this case, we have our stager code. We are setting specific URIs for the x86 or 64-bit versions of it, and it's just included in that section of our valuable profile. Same concept with post. It has exactly what we need there. And now when it comes to how do you set up your Cobalt Strike listener, well, the nice thing is all you need to do is just specify that top-level subdomain, or the whole domain, including your own subdomain that you're using, that you define with your function, and that's all that's needed. You can just specify port 443, and then in this case, we're providing that the host and the beacon to go to is webdeliveryonline.azurewebsites.net. So let's talk everyone through an example and how this works, and we'll get our beacon. So in this case, I'm showing that we have our GET code right here. That is the location of it. We are forwarding on our request to, this is the location of our team server. If you notice, the difference is we are not using API within our call or within the URL. It is using 40 North. We're capturing all the headers. Here we are making our request. So after we capture those headers, forward them on in our GET request. Once we get the response back, send that back to the original requesting server. You can see right here in our HTTP GET code block, it is using the 40 North get it for the URL, and that is basically our GET request. Same exact concept here with our post request. We just have a slightly different URL. We are still capturing all the headers because that uniquely identifies our beacon. We're going to probably scroll down and show you it. Yep. So here's our code block where we set the URI to match our function code. The big difference here is obviously we're getting all of the data sent in the post request. We are making sure that we are forwarding all that data from our function to our team server. And then again, just capturing the response from the team server and sending it back to the original requesting beacon. Finally, in this section is where we just have like our staging code. We're just showing that in this case, we're only setting a URI for the x86 staging beacon, and same concept as our GET request. All we're doing is just capturing all the data from the original request, forwarding it onto our team server, and then sending it back to us. Here's an example. I'm going to go ahead, I believe, and push this code to this function that I call a redirecting function online. So I'm going to click this deploy to function app. I'm going to select my subscription, in this case, the pay-as-you-go. I'm going to have it use my redirecting function that was created. And it's going to ask me, do I want to make sure that I'm going to deploy this there? And I just click yes and tell it to deploy. And then Visual Studio Code is going to start just doing its magic, make life super easy, and it's going to package everything up in a way that Azure can handle. So as you can see right now, there are no beacons. There's nothing checking in yet. So we're just trying to show that it is empty. But what I'm going to do is go ahead and just really quickly create a PowerShell one-liner that we can test and make sure our function code does work and does actually forward our request to the team server, and we do get our beacon. So I'm saving that to disk, and you're about to see me open up and copy and paste that Azure function code, which right here is just in this payload.txt file. So I'm just going to go ahead and copy and paste that entire PowerShell one-liner, and we're going to run it on a Windows virtual machine. So over here is our Windows VM. I'm just going to open up a command prompt right here and paste this code in once we paste it in. I'm also opening Task Manager just to show that PowerShell does open, and you're going to see that we are getting a beacon through PowerShell in this. So we're pasting it, and I think before we do this, I'm going to go back here and I'm going to check that I actually did, everything is deployed, so we can see we have our URIs. The difference here, though, is it does show /API is within our URI, right? We can see all the different function trigger URLs, but I don't want to use API, but that is the default what's set by Azure Functions within Azure. The nice thing is you can change that value. If we modify the host.json value, you can change it. In this case, I have it set to 40 North. Well, the interesting thing is, if you look in the Azure portal, it actually does show that my my trigger URL does actually use 40 North. It's a small bug, I think, in Visual Studio Code because it doesn't actually print out the proper URL if you change that API value. Long story short, we run our PowerShell one-liner, and you can see that our beacon did indeed check in, and this is all being forwarded back and forth to us, to the team server, from my victim system using an Azure. That's that. Matt, I'm going to hand everything over to you for the next part.
In addition to using those Azure functions, which are pretty great, you could also use Ngrok for serving up some local infrastructure for your red teaming. So kind of some background on the tool itself. It's an easy way to tunnel traffic from a VM or some other like local machine to an external address that you can reach, over the internet. The tunnel is encrypted, which is really nice. And if you get the paid version of it, you can use custom domains, which I'll kind of talk through later here. And it also gives you the option to run multiple concurrent tunnels at one time with just one config file that I'll also show you here in a few slides as well. So some of the pros to using Ngrok, you can quickly set up any type of local infrastructure and you can make it reusable as well. So there's no need to use domain fronting. Really, this Ngrok tool acts as your redirector. And one thing I kind of learned as going through this is, some EDR products don't usually follow a CNAME record, which is what you set up when you set up a custom domain to use with Ngrok, which I'll show as well coming up. And I don't know exactly how often it rolls it, but Ngrok usually rolls its external IP address pretty regularly. I want to say every couple days or something similar to that. There's one inside out use case that I'll talk about here, but I know there's a lot more. And there's a ton of other things you could do with Ngrok as well. You can, serve up a local directory for file sharing. You can set up HTTP authentication, a bunch of different things. It's a really, really powerful tool. Some of the downsides to using this, you can use domain fronting with it, but it's kind of just like a necessary step just because you'll be using that custom domain and that's what you'll use as your redirector. Another downside is the infrastructure is probably going to be running for like a local VM. So if that VM dies or something gets shut down on your local network, that tunnel dies, that Ngrok tunnel will die. So that's something to be aware of. It's not really meant for extended red teams. just a way to kind of quickly set up infrastructure and get it going. Another thing that I noticed during testing is your external IP address doesn't get recognized in Cobalt Strike. I'm sure there's a way around this to pass that through another way. Just haven't taken the time to try to fix that or look for any solution yet. And then kind of with all red teaming, you have to plan a little bit before just to be aware of, what ports and services you want running, where do you want your beacon to call back to, everything like that. And so kind of to set everything up, you'll probably want a paid account. And that way you'll be able to use a custom domain that you have. You'll be able to categorize it, age it, whatever you need to do depending on your situation there. And it's really easy to get set up after that. All you have to do is create an account, download this Ngrok binary, and then just follow this authenticate or the dashboard to authorize it, which is just one command. And the only thing that you will have to note is later on I'll show you a config file here. You will have to have that authorization key inside your config file. Even if you already authorized like your local system, you'll still need that key in that file. And then you want to reserve whatever custom domain you're going to be using on the Ngrok dashboard. And then you'll set the CNAME record in your DNS for that. So this is kind of what you'll see on the Ngrok dashboard. You'll see that we're just using My Healthy Clinic as a test here, and I set that CNAME record that it gave me. And once DNS propagates and everything, there's a way to just click check status. And once it's correct, everything's working, and you can start setting everything up after that. So what we want to do as well is we'll set up a TCP address so we can use Cobalt Strike and have other people connect remotely to our local infrastructure here. And so one thing you could do is just test that Ngrok's working right with using this HTTP protocol option, specifying your custom domain, and then just over port 80. You'll see something similar to this if you're not serving up like Apache or Apache isn't running or anything like that. You'll see something similar to this error message, but then you know that the tunnel is actually working correctly. So the next thing you'll probably want to do is you want to set up some certificates. You want to make sure your domain is actually protected, and when people go to it, they see that the lock icon, which makes everything secure, right? But what's nice about this is you can run certbot locally. So you'll just have to have Ngrok running with that last command over port 80, and then you can run certbot, which will do a challenge. You specify the HTTP challenge, and once that's done running, you can test it out with the TLS option, and then just to specify port 443 with that. And hopefully when you go to your custom domain, you'll see something similar to this, and you'll see like HTTPS as well for that. Or if you say serve up a web page with Apache, that should serve that. The cert should work out. So this is an option for the config file that we have set up. We just have a couple different ones here. So you can see at the top that you have to specify the auth token in there. I think that took me a little while to figure out. But the next kind of the three sections are different tunnels that we have. So for this, we're using HTTP beacon, HTTPS beacon, and the team server address. We're serving up a TCP port there. So for, of course, the HTTPS, you'll want to specify whatever host name you're using. Before we were using My Healthy Clinic. We're just making sure that we want to bind TLS and then specify the TLS protocol. For the next one, pretty much the same thing, except we'll set false, bind TLS to false, and then the protocol is just HTTP. And then this team server access, as we'll be showing you in a second here, what we want to take note of is this remote address. We'll use that for connecting to the Cobalt Strike team server. If you want, it might make it easy to serve up a local directory just for, file sharing or easy access to whatever payloads you have, depending on your situation. But you could also just add that into the config file as like another option. And here we're just calling Ngrok with the start flag, specifying whatever config file we have, and then you just have to specify the tunnel names that you want it to create, and then it'll look something similar to this. You can see that it's forwarding these URLs to our local host. And so the next thing you want to do is connect to your Cobalt Strike team server that you have running on your local system. And here's where you kind of want to take note of that remote address. So this host is usually always going to be the same, but the port is what's going to change. That's what you specify in that config file. And this is the port that's given to you when you reserve a TCP address through your Ngrok dashboard. And so the next thing you want to do is just create your listeners, make sure everything is working right. This is probably something that a lot of you have already done. It's pretty similar to, setting up any other listener for any other like redirector, pretty much the same for HTTP, HTTPS. And then once you get this all set up, you want to test it out just to make sure everything's connecting properly. And as you saw in Chris's demo, our go-to is kind of like a PowerShell one-liner, just makes it super easy to test out. And this is what you'll see once you get a beacon back. You can see the external IP address doesn't really populate. It doesn't know what to do with that. Once again, there's probably a way around it, but I haven't looked into it. But you should be able to interact with that, get a process list, everything like that. But it'll be going through that Ngrok tunnel that you have set up. So another interesting way that you could use this is more of like an inside-out approach. So yeah, like talking web shells, in 2020, that's crazy. But it does require dropping the Ngrok executable on whatever your victim system is or whatever like the server you're targeting. But that binary is non-malicious. There shouldn't be any malicious code in there. It also requires you to serve up a local page on that system, which is your web shell. At least me, I'm paranoid. You're probably going to want to set up multiple authentication mechanisms for this. So maybe one authentication mechanism with your web shell and one for the TCP tunnel, Ngrok, depending on how you want to do that. So some pros to this are you don't need to drop any payloads on the system. There's no malicious code. If you do use like a default web shell, that might get flagged, that might get caught. But if you roll your own, that shouldn't get caught at all. That's not something I don't think anything really looks for. And it should traverse the firewall just because it's kind of poking a hole from the inside out. Final thoughts for like using Ngrok as a redirector. Of course, modify any of this to suit your needs. A lot of it can be customized pretty easily. You can serve whatever other ports you want. You can serve up a local directory, set up some authentication for HTTP or HTTPS. You could, like we just talked, you could use this as a form of persistence, which is kind of like an inside-out approach to this. Doesn't require dropping a couple files on the system. But, if you're using registry persistence or something else, you're probably going to be dropping a file on there anyways. And, just make sure that you set up authentication with this, definitely, because you're serving up that local file. And if you're not setting up any authentication on your Ngrok tunnel, you could be serving that up to the world. So make sure to set up authentication. And one nice thing is you can easily modify your tunnel, that config file that we have set up. You can easily modify that to serve up other domains. So you could have several domains set up, act as like several redirect. One domain gets blocked, you can have your beacon, set to check these several different domains to call back on. So you can use kind of one local infrastructure for several different redirectors. So yeah, I think that's all I had.
Yeah, thanks a lot, Matt. Hopefully everyone was able to take something away from this talk. Ngrok is really, really glad. There's a whole lot of different ways that you can apply that technology, both from an outside perspective and like Matt was talking about, from an inside perspective. There's a lot of fun things that you can do with it. Same thing with Azure Functions. Like, why deploy entire VPSs when you don't need to? Why not just let Azure decide to deploy your code and use it anywhere within its cloud environment where needed? We obviously showed a demo of a fairly basic, you could almost argue like a dumb redirector at this point with our Python code within the Azure function. However, you can obviously dress that up. You can add your own capabilities looking at it to decide, like, do further inspection on the request coming in. Like, is it coming with a known user agent that you expect? Is it from known IP ranges you can expect? Basically anything you can do in Python, you can do to help inspect traffic, filter out as needed before you send it on to your team server location. Otherwise, I hope everyone enjoyed this. Thank you so much for your time. We did publish proof of concept code on GitHub, so if you want to look at what that basic Azure function code looks like, go ahead and check it out. We also published a blog post trying to explain a lot of these similar concepts on our website. Otherwise, thank you very much, and hope you enjoyed this talk.
And thank you very much. Once again, great presentation. There's nothing like a POC and a mic drop. What is the proper way to pronounce Azure?
Oh,
Azure.
God. I say Azure. I probably mispronounce it multiple times throughout it. I say Azure, and I'm sure that there's someone going to make fun of me about that, though. So who knows?
Any tips on hunting this besides looking for AzureWebsites.net, maybe secondary indicators?
That's a great question. I think it's hard, right? Because anyone can write their own custom code. So you don't necessarily know what's going on the back end and what they're doing. I think the biggest thing is right now, the only subdomain that I've ever seen anyone, or domain that has been used for Azure Functions, is the AzureWebsites.net. So I would start with that. If you're seeing that used, then it's not necessarily indicative of evil, but you can check out to see what's making web requests to that. Additionally, if you're seeing that /API in the URL to that AzureWebsites.net domain, then it's likely that there's a web trigger going on. Someone's using it and they're using like the default setup like that. I think right now, just because of the customization capabilities that you have, that the main thing that I would look for is what's talking to those AzureWebsites.net subdomains and trying to see what else I can do to determine what it may be doing on the back end.